This is Unit 5, Right Triangles, Lesson 5.2, Special Right Triangles. Make sure you get the date, time, and location that you're watching this video. Turn off all distractions. Do not attempt to multitask while you're watching this video. We learned we're starting this entire unit focused on the 5 tools that we can use with right triangles. This is called the right triangle toolbox. And the first one that we learned was simply this. If you have 2 sides and you need a 3rd side, Pythag. Have 2 sides, need 3rd side, Pythag. Say it with me. Have 2 sides, need 3rd side, Pythag. So we learned that if you have 2 sides of a right triangle and you need a 3rd side, you use Pythagorean theorem. Let's go ahead and write that down right here. This is the preferred version of that. Leg squared plus leg squared equals hypo squared. You guys commonly know it as a squared plus b squared equals c squared. I will never use that. Why? Because students get confused. Which side is A? What is B? What is C? I much prefer what's called the descriptive version. So we're first going to label our 2 legs connected to the right triangle. That's one leg. That's the other leg. And then the hypo is always across the right angle. That is your hypo. Now that you've labeled, let's circle plug chug. Leg, leg, 3 squared, plus leg, leg, x squared, equals hypo, hypo, 6 squared. I'm going to get you part of the way through the math here. 9 squared, or 3 squared is 9, x squared, and this is 36. Our goal is to get x completely by itself. So we're going to minus 9 both sides. The opposite of squaring is square rooting. The opposite of squaring is square rooting. Not divide by 2 there. So when we square root 27, we're going to factor. Three has a date, they're going to come out. This 3, no date, stays home. Our final answer for this is going to be 3 root 3. Let's do this one together. Have 2 sides, need 3rd side, Pythag. First we label our legs and our hypo. Hypo is always across from the right angle. That's your hypo. Then we establish this is a leg and this is a leg. So we write our equation. Leg squared plus leg squared equals hypo squared. Please always write the equation, even though you know it. Then we physically circle plug chug. One leg is going to be x squared. The other leg, we physically circle it, is root 7. Put the parentheses around that squared, equals hypo 2 root 3, put parentheses around that, squared. Exponents expand. Exponents always expand. Let me show you what I mean by that. Do not square in your head. Root 7 squared looks like this. Root 7 times root 7. 2 root 3 squared looks like this. 2 root 3 times 2 root 3. That's what expand means. Do not square those in your head. This is still x squared Root 7 times root 7 is just 7. 2 times 2 is 4. Root 3 times root 3 is just 3. 4 times 3, this is going to become 12. Stay right with me. A minus 7 both sides. We have x squared equals 5. Of course, we square root. If we can't simplify, we simply leave it under the radical sign. So this x is simply going to be square root of 5, because there's nothing else you can do there. Have two sides, need third side, Pythag. Today we're going to be focusing on a concept called special right triangles. There is something special about them. You should have some colors. We're going to review Pythagorean theorem. We're going to focus something called the 30, 60, 90 triangle, 45, 45, 90, isosceles right triangle, special right triangle. We're going to be focused on patterns. There is a super important pattern you have to be able to spot when you're working with this in radicals. So let's do this first line here. Root 3 times root 3. Technically, that is square root of 9, which becomes a square root of 9 is perfect, becomes 3. Root 2 times root 2 technically is the square root of 4, because 2 times 2 is 4. But that is perfect. That just becomes 2. What you're noticing is any radical times itself is just the number on the inside by itself. So I want you to get rid of this middle step and look at it like this. Root 3 times root 3 is simply 3. Root 2 times root 2 is simply 2. Ready? Knowing that pattern, root 5, 7 root 5 times root 5 looks like this. Root 5 times root 5 is 5. 7 times 5 is 35. Root 7 times root 7 is simply going to be 7. And then you have this 3 on the outside, so 3 times 7, 21. Root 5 times root 5 is simply 5. 2 times 5 is 10. Root 6 times root 6 is 6. And then you have this coefficient 3. 3 times 6 is 18. Study the patterns you see in these two rows. Now, I'd like you to do these two rows completely on your own. Pause the video, do your own work, hit play when you're done, correct in red. Do not copy. Pause. Welcome back. You should have worked in pencil. Now get your red pen and let's correct it. Ready? This is going to be, that's 2, 3 times 2, that's 6. That's 3, that's going to be 12. That's going to be 6, that's 30. This is 10, 5, that's 2. 5 times 2, that's 10. This is 3, 7 times 3 is 21. And then root 6 times root 6 is 6. 8 times 6, 48. Now that you're comfortable with that pattern, let's try a couple more. When you square a radical, it's super important that you expand your exponents. So 6 root 2 squared becomes this. Exponents expand. Exponents expand. Exponents expand. Now we can do this. We know that 6 times 6 is 36. Root 2 times root 2 is simply 2. Therefore, 6 root 2 squared is 36 times 2. 72 is your answer. Exponents expand. 5 root 3 squared looks like this. Five times 5 is 25. Root 3 times root 3 is 3. Therefore, 5 root 3 squared is 75. Then using these patterns, you have to be able to think backwards. For example, 5 root 2 times what is 10? We know we have to get rid of that radical. Why? There's no radical over here. The only way you get rid of that root 2 is timesing by another root 2. Watch what happens. Root 2 times root 2 is 2. 5 times 2 is 10. So what goes in this box is simply root 2. Look at this one. There's no radical in the answer, so you have to ask yourself, what do you multiply by to get rid of root 3? And I know I have to have another root 3. But root 3 times root 3 is only going to give me by itself 3, and somehow I have 9 here. So I ask myself, what times 3 is 9? And the answer is 3. So the complete box, fill in the blank, is going to be 3 root 3 in that box. I'm going to give you 10 seconds to try to do that last box on your own. You've got 10 seconds to figure that out. Okay, hopefully you actually spent a little bit of mental energy trying to figure this out. Let's start with what you know has to be in there. You know a root 2 has to be in there. Why? Because we somehow have to get rid of that radical to get 1. So let's put a root 2 in there. But you're like, wait a minute, root 2 times root 2 is 2. How do I get to 1? Well, 2 divided by 2 gives us 1. So the complete answer that goes in that blank is root 2 divided by 2, or root 2 over 2. Now, with these additional patterns, I'd like you to complete this section on your own. Pause the video, start when you're done, get a red pen in hand to correct. Pause. All right, welcome back. Let's see how you did here. I'm just going to fill in the answers. We need a root 2 here to get 6. We need 2 root 5 here to get 10. Root 2 here to get 12. 7 root 3 to get 21. Root 6 over 6 to get 1. This is going to be right here, 16 times 3. So that's going to be 48. And this is going to be 9 times 5, so that should be 45. Check your answers. They're correct, some sort of smiley, yay, I'm wonderful, star. If you're incorrect, I'd like you to redo the work in the margin until you understand how to do it. Now that you have these patterns with radicals under your belt, we can focus on what we're learning today. Our first tool in our right triangle toolbox, We use the Pythagorean theorem with right triangles when you have two sides and you need a third side. Pythagorean theorem, Pythag. Have two sides, need third side, Pythag. Find your hypotenuse right off the bat. There's your hypo. Label your legs. Let's do this one together again. Just for practice, leg squared plus leg squared equals hypo squared. Yes, you will write that every single time you use it, without exception. Circle plug chug, that's x squared. You want to solve for x here. So x squared plus 36 equals 81. X squared equals 45, square root of 45. 5 times 9, 3 and 3. The 3 comes out. The 5 stays under the radical. So our final answer here for this missing leg is going to be 3 root 5. Have two sides, need third side, Pythag. But there is an exception here, and these exceptions are called special right triangles. If you have a special right triangle, you only need one side, and you can find the other two sides using specific pattern tables. Pythagorean theorem is usually have two sides, need third side. But in these two special cases, you only need one side, and you can get the other two sides, and you're going to be using special tables. There's only two special right triangles. These are special circumstances. And those are what's called an isosceles right triangle. So two sides equal. You have 90 degrees. If those two sides are equal, these two angles must be equal, which forces them to be 45 degrees each. So your first special right triangle is a 45, 45, 90-degree triangle. That's one of two. Your other one, you have your right angle. Your smaller angle is 30 degrees. Your larger angle is 60 degrees. This is called a 30, 60, 90 triangle. 30, 60, 90-degree special right triangle. Both of these have the title of special because they have special, unique patterns that you can solve using those patterns when you only have one side instead of two. Let's take a look and see what those patterns are. Let's do, both of these are 45, 45, 90 triangles. Do you see that? 45, 45, 45, 45, 90. We're going to use the Pythagorean theorem to solve. So right here, we have one leg of 4, 4 squared. We have another leg of 4, 4 squared, which makes sense because if I have two congruent angles, these should be congruent. And then I have my hypo, which is going to be x squared. We're going to solve here. The opposite of squaring is square rooting. Now we're going to factor 32 here. Bring out your dates, which are 2 sets of 2's. This 2 stays home. And your final hypotenuse is going to be 4 root 2. So one leg is 4, the other leg is 4, and the hypo is 4 root 2. Let's check this one. We have one leg, which is 5 root 2. We have another leg that's unknown and a hypotenuse, which is 10. So leg squared, that's 5 root 2 parentheses squared plus x squared equals our hypo, which is 10 squared. Exponents, we expand. Exponents, expand. 5 root 2 times 5 root 2 plus x squared equals 100. That's 25, that's 2, that's going to be 50. Plus x squared equals 100. X squared, you minus 50 both sides. Opposite of squaring is square rooting. Now we're going to factor 50. Five comes out. 2 stays home. So our leg here is going to be, as we can see, 5 root 2. Now, there is a pattern. Both these triangles follow the exact same pattern. It is your job to figure out what that pattern is, and it's the exact same one for both. So ask yourself these questions. 1, what do you notice about both legs in both circumstances? What do you notice about both legs in both circumstances? 2, what do you notice about the pattern at an end there? What do you notice about the pattern from either leg to the hypo? So going from 4 to 4 root 2, 5 root 2 to 10. It is the same pattern for both. What happened? How did we get from 4 to 4 root 2 and 5 root 2 to 10? We did the exact same thing. I am not going to fill those in for you. I'd like you to take about 30 seconds and really rack your brain. What is the pattern for both of these? Pause the video if you need to. Okay, let's see if you guessed correctly. So in a 45, 45, 90 triangle, the pattern is this. The legs will always be equal. That's a simple one to understand. If you have 2 congruent angles, you have 2 congruent sides. The length of the legs will always be equal. The hypo will always be whatever a leg is times root 2. Now, warning, you just don't artificially tack on a root 2. You go through the process of timesing by root 2 to get from the leg to the hypo. So what you should have noticed here is that the legs were equal. Legs were equal, and legs are obviously equal. To get to the hypo, you simply times by root 2. So 4 times root 2 is 4 root 2. 5 times root 2. Now you can see why we did all that radical stuff. 5 root 2 times root 2 is 10. So that is the pattern for all 45, 45, 90 triangles, is that the legs are equal. Leg equals leg. The hypo is whatever the leg is times root 2. I'd like you to chant this with me. We're going to do it 3 times. I'm clapping, you're clapping. 45, 45, 90, leg, 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 root 2. 45, 45, 90, leg, 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 root 2. 45, 45, 90, leg, 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 root 2. Okay, I'm not joking here, folks. I'd like you to clap with me. Do the next one with me. And 45, 45, 90, leg, 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 root 2. One more time. 45, 45, 90, leg, 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 root 2. Let me show you how this pattern works. It makes it super easy when you know this pattern, because now you only need one side. But this pattern only works when you have a 45, 45, 90. Do not use this with any other triangles. We have a 45 here and 90 here, which implies there has to be a 45. So 45, 45, 90, leg, 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 root 2. If one leg is 3, the other leg is 3. The hypo is whatever the leg is times root 2. So in this case, y is going to be 3 root 2. Let's come down here. We're like, uh-oh, there went my legs. What happened? Step 1 is whatever A is, B is going to be. So you solve for one, you got the other. To get this hypo, we had to times by root 2. So it looks like this. This is why we did the blank. Something times root 2 gave us 8 root 2. And say that out loud. Something times root 2 is 8 root 2. Say it one more time. Something times root 2 is 8 root 2. Ask yourself, what's the something? I'll give you 10 seconds to figure that out yourself. Something is simply 8. 8 times root 2 is 8 root 2. And whatever A is, B is going to be the same thing. Let's try one more together. You're going to do a couple on your own. Again, the pattern is 45, 45, 90, leg, 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 root 2. So problem is both our legs are missing again, but you get one, you have the other. Put a box here at one leg, draw a hypotenuse towards the hypotenuse. To go from a leg to a hypo, we times by root 2. Leg to hypo. So we write it like this. Something times root 2 gave us the hypo, which is 10. What's the something? Which is the same as that something. Something times root 2 is 10. You've got 5 seconds to fill that out. Your something is 5 root 2. Why? Because 5 root 2 times root 2 is 5 times 2, which is 10. So this x and y are both going to be 5 root 2. 45, 45, 90, leg, 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 root 2. Use this pattern for the 45, 45, 90 triangle. Solve for both of these. You're not using Pythagorean theorem. You're using this table. Why? Because it is a special right triangle, the 45, 45, 90 table. Pause the video, do your own work, then correct. Pause. Welcome back. Let's see how you did here. So 45, 45, 90, leg, 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 root 2. So your legs had to be equal. If that's 4 root 2, this was 4 root 2. You times by root 2, you should have gotten 8. This you work backwards. Something times root 2 gave you 6. Your something here is 3 root 2. And this should have been 3 root 2 as well. Why? Because legs are equal in a 45, 45, 90 triangle. That's one pattern for one specific special right triangle. And that special right triangle is a 45, 45, 90. Now we're going to do one more, which is the other special right triangle. There's two categories, and this is the 30, 60, 90. 30, 60, 90. We're going to start by using the Pythagorean theorem. But we have to label our triangles here. We have a 90. 30 is the small angle, so that makes the 5 a short leg. 60 is the larger angle, that makes this the long leg. That's going to come in handy. It's really important you establish the difference between the legs. The legs are no longer equal now. Why? Because the angles aren't equal. So there is your 30 smaller angle, which makes x here the short leg. Here's your larger angle, 60, which makes the 6 the long leg. Now let's go ahead and just use the Pythagorean theorem to solve here. Leg squared plus leg squared equals hypo squared. So our one leg here is 5 plus our other leg here is 5 root 3 squared equals our hypo, which is x squared. We're going to solve. Five root 3 squared looks like this. 5 root 3 times 5 root 3. 5 times 5 is 25. Root 3 times root 3 is just 3. That becomes 75. Equals x squared. X in this case is 10. Let's try another one. Our short leg this time is our unknown, x, plus our long leg is 6 equals our hypo, which is 4 root 3 parentheses squared. Four root 3 times 4 root 3, let's write that here. Always expand it, show your work. 4 times 4 is 16. Root 3 times root 3 is 3. 16 times 3 is 48. We're We're going to solve x squared minus 36 both sides. (36) from 48 is 12. We square root. Let's factor. Four times 3, 2 and 2. The 2's come out. X is 2 root 3. So our short leg this time is 2 root 3. There is a pattern here. There's 2 of them. I want you to figure out these 2 patterns first on your own. I'm not going to figure them out for you. It's your job to figure them out. I'm just going to highlight them so they're easy to spot. The first pattern is, what do you notice from the short leg to the hypo? So the short leg here is 5. The hypo is 10. The short leg here is 2 root 3. The hypo is 4 root 3. 5 to 10, 2 root 3, 4 root 3. There is a pattern from the short leg to the hypo. Write down, what do you notice in both circumstances? Next one, what do you notice between the short leg to the long leg? We have 5, 5 root 3, 2 root 3, 6. 5 becomes 5 root 3. 2 root 3 becomes 6. There is a pattern. Something that happens to the short leg to get the long leg. I'd like you to try to predict what is that pattern. This only happens in 30, 60, 90 triangles. Take about 10, 15 seconds to write that down. Let's see if you understood the pattern. The first pattern was this. Whatever the short leg is, I'm going to call it the SL, short leg. The hypo was twice. From the short leg to the hypo, you times by 2. From the short leg to the hypo, you times by 2. You should have noticed that on this side here. 5 times 2 is 10. 2 root 3 times 2 is 4 root 3. That was one pattern. Short leg to the hypo is times by 2. Short leg to the long leg, you times by root 3. 5 times root 3 is 5 root 3. 2 root 3 times root 3 gave you 6. It's the same pattern. So the long leg is whatever the short leg is times root 3. Write it down just like this. Short leg times root 3. This pattern only works for 30, 60, 90 triangles. Get ready to chant. Chant with me. We're doing this several times. Ready? And 30, 60, 90. Short leg root 3, short leg times 2. Again. 30, 60, 90, short leg root 3, short leg times 2. 30, 60, 90, short leg root 3, short leg times 2. One more time. 30, 60, 90, short leg root 3, short leg times 2. This only works for a 30, 60, 90 triangle. Notice what's repeated every time. Notice everything is related to the short leg. So that is the very first thing you find is the short leg in these triangles. I'm going to do several with you. Ready? Okay, if that's 60 degrees, that has to be 30 degrees, which would make the 3 the short leg. Now, I do my pattern. Short leg to the hypo times by 2. Short leg to the long leg times by root 3. So if my short leg is 3, 3 times 2, my hypo in this case will have to be 6. And 3 times root 3 simply becomes 3 root 3. Let's try another one. Again, always start by finding the short leg. The short leg is across the 30 degrees. If my 30 degrees is here, that makes B here my short leg. Now, draw your sprouts, your sprouting arms. One arm goes to the hypo, times by 2. One arm goes to the long leg, times by root 3. Problem is, this time you don't have the short leg. Let's zoom in. You can see in the pattern here, it reads like this. Some unknown number times root 3 is 6 root 3. Some unknown number times root 3 is 6 root 3. You should see that your unknown number here would be 6. So we put a 6 there. And then 6 times 2 is 12. Always start by identifying your short leg. We're going to do 2 more together. That's my 30 degrees. So that means my short leg here is Y. So I'm just going to put SL. 30, 60, 90. Short leg root 3. Short leg times 2. To the long leg times root 3. To the hypo times by 2. So this reads now, there's nothing there at the short leg. So draw a box. We have here something times root 3 gives us that 6. Something times root 3 gives us 6. And you ask yourself, what does that something have to be? And we know we need a root 3 there because root 3 times root 3 gets rid of that radical, which is 3. But when we need a 2, why? Because root 3 times root 3 is 3, and 2 times 3, that'll give us 6. So our unknown short leg that we are missing is 2 root 3. And you simply times that by 2 to get your hypo. So that's going to be 4 root 3. Always start with your short leg in 30, 60, 90s. This one gets a little tricky. That's 30. That makes this our short leg. 30, 60, 90. Short leg root 3. Short leg times 2. Once again, we don't have our short leg. So it reads like this. Something times root 3 gives us 3. I'm going to give you about 10 seconds to figure that something out completely on your own. Something times root 3 is 3. Ask yourself what goes in there. You should have figured out to get rid of that radical, we needed a root 3 there. Root 3 times root 3 is 3. So this is root 3. Simply times by 2, that's 2 root 3. Again, this pattern only works for 30, 60, 90 special right triangles. This page you're going to do completely on your own using that table. Pause the video. Restart when you're done. All right, let's see how you did here. Our short leg here is 6. Short leg to long leg, that's going to be 6 root 3. Short leg to hypo, that's going to be 12. We don't have our short leg here, but we had to times by root 3 to get 4 root 3. That means your unknown would have been 4, and then going this way times by 2 would be 8. This one, again, you didn't have the short leg, but short leg to long leg times root 3, that means what times root 3 is 9. Your unknown here is 3 root 3. Double that, that is 6 root 3. If you did it correctly, star, smiley, something like that. If you didn't do it correctly, I'd like a note. What are you going to remember next time? I highly recommend you take the time to actually go back, flip through the last few pages of these notes, set a timer on your watch or your cell phone for 2 minutes, and verbally summarize what you've learned today. And try to visualize the solution to a single problem. That will help cement today's content in your brain for the long term.